We're now going to talk about part 2 of case study ex4. And this case study is going to, again, apply a bunch of flux operators like flat map and subscribe to create, multiply, and display big fraction objects asynchronously. And this version will apply back pressure using the registered subscriber. So we're actually going to give it a count to say only send a couple of items per window. So you'll see how that gets used in a second, but it's done by passing in a blocking subscriber that has that value set. This example also shows a couple of other interesting mono operators, including from supplier, repeat, and then some calls that take place in multiply fraction. And it also shows how to use the generic blocking subscriber, which happens to be back pressure aware, because as you can see here, it's got this call that will request a chunk size that is not max value. So it'll be much, 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 much smaller. So now we're back in the ex4 project. This is the ex4 driver. Last time I looked at test fraction multiplications blocking subscriber. Now we're going to look at blocking subscriber 1. Now we're going to look at test fraction multiplications blocking subscriber 2. And this actually applies back pressure. So here's how it works. We've talked about some of this stuff before, so I don't have to revisit it in detail. The first thing we're going to do, or the second thing we're going to do, is we're going to make ourselves a blocking subscriber, just like we did before. The difference being, unlike last time where we passed in the max value, this time we're going to pass in a value of 2. And what that means is that the publisher will only send or only emit 2 values, and then it'll have to wait for the subscriber to ask for the next or to ask for the next chunk of values, in which case it would be 2. So that's the way this is going to work. And what we're going to do is we're going to have a from supplier that generates a random big fraction. And then we're going to use the repeat operator to repeat this S max fractions minus 1 times. So that'll end up generating a total of S max fractions big fraction objects. There's 10 of these. That's what that's set to. So this is the first one, the from supplier, and then we do 9 more. So we're going to generate 9 random big fraction operators, which is kind of cool. Then we're going to use the flat map concurrency idiom to multiply each of those random big fractions by some constant in parallel using the schedulers.parallel method. That's the parallel thread pool that works for computationally intensive tasks. And this multiply fraction method is the same as the one we looked at before. It's just going to multiply the 2 big fractions together in the scheduler background thread. And there could be different threads all running simultaneously. We're then going to go ahead and register the blocking subscriber with subscribe. Now remember, this blocking subscriber is back pressure aware. And then we're going to go ahead and have the calling thread wait for all the asynchronous computations that are taking place here to finish, at which point it will be released when onComplete will finish and release that latch. Remember, there's a countdown latch lurking inside of a wait. And if you take a look at the implementation, you can see it's just blocking on that countdown latch until the value goes from 1 to 0, until it's counted down. So the main thing to note here is that this is a back pressure aware and is back pressure aware. Let's put that in quotes because that's an important concept to understand what we're showing here. This is a back pressure aware subscriber. And just to recap that very briefly, here's blocking subscriber. And this is the part that makes it back pressure aware. Here, when the onSubscribe method is called, we pass in the request size. We set the request size to 2 in our factory method. So that's going to say to the publisher, only send 2 items, and then don't send any more until the subscriber detects that we've processed everything that came its way and asks for the next chunk. So it's going to ask for the next 2 items at that point. OK, so let's go ahead and take a look. If we run this program, which I already ran this before, this is what the results look like. So this is the results for test fraction multiplications blocking subscriber 2. So you can see we start off our asynchronous processing. We generate 2 results. The publisher pushes 2 results. The subscriber then says, OK, thank you. Please send me 2 more. sends us 2 more, waits. Subscriber says, please send me 2 more. Publisher sends 2 more, waits. So you can see this kind of flow control. Now, honestly, having a buffer size of 2 is rather small, but I didn't want to make this example fly off the end of the screen. So I just wanted to show you what it's doing. So it's asking for 2 each time, and eventually it gets them all. And at that point, it's finished, and it will print 10. It prints the results, which is 10 async computations completed successfully. So everything is very happy. It worked fine, and we have a back pressure aware subscriber. Now, the thing to note about this is that the back pressure aware subscriber here is based on the number of items sent. It's not based on the rate of sending. Now, you can also have your publishers send at a particular rate. There's ways of being able to delay the rate at which things are sent. There's a whole bunch of different ways to do that. You could use the interval factor method to do that. You could do it through other things like delay and so on. But note that back pressure mechanisms that we've been looking at are not rate-based, they're size-based.